Hi and welcome to video 1 for section 9.2. This will be the only video for this section. So in 9.1 you kind of had information overload. There was 4 videos, the introduction to the vectors, magnitude of vectors, horizontal components, vertical components, the plane or the salmon problem. So we're going to slow it down a little bit here. In 9.2 we're going to look at one and only thing, and that is what's known as dot product. So it's a pretty straightforward concept, but the math behind it, people tend to mess it up, quite honestly. So as I go through it, I'll try to point out where sometimes people get a little bit awry, so that hopefully you guys don't make the same mistake. But if you have any questions, if there's any confusion, make sure in class or make sure office hours you ask me the questions you might have. So first, let's look at a definition. We have that if U is some vector with components A1, B1, and V is a vector A2, B2, then their dot product and we denote this as U dot V. So this isn't U times V. We're not multiplying these vectors. We will do some multiplication, but we're not just multiplying these things together. So this is U dot V. So this dot product, U dot V, is defined as the following. So U dot V is equal to A1 times A2. So I multiply the two A values together, and then I add to it B1 times B2. So note, what am I doing? I'm multiplying two numbers, multiplying two other numbers, and adding them together. So what do I get? I get, so U dot V is a real number. It is not a vector. And this is where people run into trouble. They do the dot product, and then they try to give me something like this, and they have some number in between here. It's not a vector anymore. It's a real number. So let's look at an example. So the first one, if U is equal to 3, negative 2, and V is equal to 4, 5, we want to find U dot V. So by definition, U dot V is A1 times A2, so 3 times 4, plus negative 2 times 5. So that means 3 times 4 is 12. Negative 2 times 5 is negative 10 minus 10. So U dot V is equal to 2. That's it. Just a number, we stop right there. That's our answer. We don't have to go any further. We don't have to make it any more tricky on ourselves. That's it. Just the value 2. Let's look at another example. I'll let you guys try this one. So U is equal to 2I plus J, and V is 5I minus 6J. And we want to find U dot V. So, first one had it in this form here, in our normal vector notation. This one has it in component form. So what you'll need to do first is convert it to this manner, then go ahead and do the dot product. So go ahead and pause, give it a try, come on back and I'll work it through for you. Okay, so welcome back. Hopefully you're able to pull this off. So if we write u with our AB form, well, in unit component form, what do we have? AI plus BJ. So u is just 2, 1. And v is what? 5, -6. So hopefully you got to that, and at this point then it's just the dot product. So u dot v is a1 times a2, so 2 times 5, plus 1 times -6, which is 10 minus 6, which is equal to 4. So in both of these cases, we ended up with positive numbers, but it doesn't always have to be positive. You could have a dot product that's a negative value. It really just depends what these numbers are. So hopefully you're able to get 4 as your answer. So the last thing for this video, we'll give you the properties of dot products. So the first one is that u dot v is the same as v dot u. Because of the property that we're just multiplying these two and multiplying those two, it doesn't matter which order we list uv or vu. We get the same value. The second is if I have some scalar multiplied by u, and then I dot product that with v, it's the same as if I do u times the scalar times v, or if I just do a times the dot product of u and v. So all three of these are the same. Doesn't really matter when we multiply the value a and then do the dot product, we're going to get the same value. If I have two vectors, I add them together, and then dot product with a third vector, w, this is the same as if I distribute. So u dot w plus v dot w. That's the distribution. The last one, if I have the vector u and I square it, this is the same thing as doing u dot u. Gives me the same value. So that's it. Short and sweet. I know after 9.1 you were probably getting, like I said, information overload. But 9.2 is really straightforward. It's dot product, and it's just by definition a1 times a2 plus b1 times b2. Gives you a real number, not a vector. As long as you keep that in mind, you shouldn't have any problem with these problems. Thank you.